Let's take a look at the surface area and volume of some unique shapes now. So we've got the cone, the sphere, and the pyramid. And sometimes the pyramid has a square base, sometimes it has a triangular base, but the concept remains the same. Okay, now in a cone, what we need to understand is that the base is a circle, and so we'll have a radius there. But we'll also, within that cone, if we drop a perpendicular from the point of the cone, we'll have a perpendicular height over there. But we also need, when we work out some of our surface area calculations, we'll need this length here too. And so sometimes that's called the slant height, so H with a little s. Sometimes they'll just call it slant, and sometimes they'll call it even just L for length. If they ask us to work out the surface area of a cone, then we need to understand that the base is part of the surface area, and that's just a circle. So circle pi r squared plus, now we need to find a formula to work out this cone part of things. And the way we do that is we say pi plus pi times the radius times that slant height. And then volume of a cone is a nice and straightforward formula, 1 over 3 pi r squared times that perpendicular height. So super important that we understand the difference between the slant height and the perpendicular height within the shape. Okay, perpendicular height needs to have a 90-degree base angle. Slant height we can work out. Okay, and they love to, in these types of questions, actually include some element of Pythagoras, because once we have this perpendicular height and the radius, we then have constructed a right angle triangle, and so we can often work out the slant height even if they don't give it to us. Moving on then to the sphere, we need to be able to work out the surface area of a sphere, and the formula there is 4 pi times r squared. Okay, and then we have a nice and simple formula also for volume of a sphere. It's 4 over 3 pi r cubed. Okay, and if ever I need to remember these two, I always remember that area is measured in square units, so I'll use the formula with the square, and volume is measured in cubic units, so I'll use the formula with the cube. And then finally the pyramid. Now the pyramid, similarly to what we saw with the cone, also needs to have a perpendicular height. So this one might be a bit tricky to draw because of that side there, but let's call that our perpendicular height. So within the shape, if we drop a perpendicular from the vertex down to the base, that needs to be perpendicular. Okay, now when it comes to the pyramid, we don't have straightforward formulas like the ones for the sphere, or even the ones for the cone. We've got to really break it up, and we've got to say, if we unfold this shape, what are we looking at, especially when it comes to surface area? And that's okay. So in this case, we've got a square-based pyramid, and that means the base of this will have side times side as its area formula. And then we need to do the sum of the triangles. So there'll be 4 triangles, and the area of a triangle is half base times height. And again, we're going to have to then introduce what is known as a slant height. So if you take the length that goes from the vertex down the side, that we'll call there the slant height. Okay, very important not to confuse the two, because there are 2 heights in that triangle formula. Okay, but definitely easier if you just unfold it and think logically. Then for volume, what we do is we'll take the area of the base and we'll apply that. Okay, so in this case we've got a square, but let's put a bit of a generic formula together first. So we'll take 1/3 multiplied by the area of the base multiplied by the perpendicular height of the shape. So that's the formula for the volume of a pyramid. In this instance, because we're dealing with a square-based pyramid, we could then say, okay, well, 1/3 multiplied by area of the base is going to be side squared because it's a square-based pyramid, multiplied by that perpendicular height over there. So if ever you are asked to calculate the surface or area or volume of one of these shapes, you need to just refer to the formula. I say often just check with your teacher. Some of them will give you formula sheets. Some of them will expect you to memorize these formulae. So make sure that you know what is expected of you when you step into your tests and exams. All right, the best way to check our understanding is to jump right in and practice some examples. Calculate the volume of concrete needed to make the post below. So if we look at this post, it's obviously part of a gate or something that we're looking at, and it's comprised of this big rectangular prism over here, and then above that a little pyramid, just to make it look fancy, I guess. Okay, so we've got two shapes, which means to calculate the volume, we're going to have to work out each of their volumes and then add together. Okay, so the volume of shape 1 is going to be so straightforward. Length times breadth times height. This is something we've been doing since primary school. Okay, so we can substitute in. It does have a square base, so the length and breadth are essentially going to be the same. So it's going to be 50 by 50 by 120. Let's calculate that. If you pop that into your calculator, you'll end up with 300,000 centimeters cubed. Remember, volume is cubed. Okay, then volume of the pyramid, we are going to need that formula that we just learned. So it was 1/3 multiplied by the area of the base. Okay, it's a square base, multiplied by the perpendicular height of that pyramid. Okay, so 1/3, the sides here are 50 and 50, so multiplied by 50 centimeters squared, multiplied by the perpendicular height, okay, that they've given to us over here. They've said if you take from here to the top, it's 10 centimeters. So we can then write multiplied by 10. And again, we type that into the calculator, and that gives us 8,333,33 cubic centimeters of concrete for that pyramid part. Okay, now to answer the question fully, we'll say, well, the total volume of concrete that will be needed, and then we're going to add these two things together. So the 8,333, I've still got on my calculator. It's always best not to round off. And then we're going to add that to 300,000, and we can round off now in our final answer. We're going to have 308,333,33 cubic centimeters of concrete needed to make this shape over here. Now, I hope you're ready to really do some calculating, because they want the surface area of this post. So basically, all of the surfaces that are exposed to the outside, they need to be included in our calculation. Okay, important to note when it comes to these, this square-based pyramid here is resting on top of one of the square faces. But technically, that whole situation is happening inside of the shape. And so that doesn't count as part of the surface area. So you've just got to be very careful. You can't just throw in a surface area formula here and expect it to work. We actually need to think about it very carefully. Okay, let's start with the pyramid, because that's going to involve a little bit more of our brain capacity. In order to work out the surface area, or just the area, let's say, of one of these triangles, I need a base and I need a perpendicular height within that triangle. Okay, so what I've got now is I can for sure say this base here is 50 centimeters, so that's okay. But I actually need to be able to work out this slant height here. And so I'm going to have to think very carefully. I'm going to take the 10 centimeters that I was given there as a perpendicular height, and this part here, because it's a right prism, this base of the triangle will be 25. And so what I've done is I've formed a triangle that I can use to calculate Pythagoras. Okay, so I'm going to do the calculation in red because my line is in red, just so we don't lose track. So we want that slant height, let's call it h with a little s there. Okay, that squared is going to equal to the sum of the squares on the other two sides. That's what Pythagoras says. So We've got a 10 centimeter side, which is easy to see. This 25 centimeter side, we just needed to think a little bit because it was the whole base would be the full square, but because we've dropped the perpendicular down to the middle, we're only taking half of the length of that square there. Okay, so then to get the slant height, we are going to square root whatever we get here, 10 squared plus 25 squared. So that gives me 5 root 29. And I'm going to leave it like that for now. I always say we don't want to round off too soon and lose the accuracy of our answers, but that's what we're going to do. Okay, so now we can work out the area of one of these triangles, these yellow triangles. Half of the base, 50 centimeters, multiplied by that little perpendicular height, which within the pyramid is the slant height. So let's do that over here. We're going to have 4 triangles. Area of the pyramid. Let's write that down. Pyramid. Okay, there are 4 triangles times by half. The base is 50 times by that height that we've just worked out. 5 root 29. So the minute you've got that, it's really not a difficult calculation. So that times by everything else that we've got there gives us a nice answer of 2,692,582404 centimeters squared. Okay, so remember we are not, in this instance, we're not including the square base as part of our surface area because it's not on the outside of the shape. Okay, now we need to think a little bit carefully about these other sides that we're working with. So let's do that. This one here is a nice and straightforward length times breadth, and 2 of those can be included in our calculation. Okay, so area of the prism, let's call it. Okay, that's going to be 2 times, actually what we should do is use the terminology we had, height, length, and breadth. Let's do that so we don't get confused. Okay, so we want to have 2 length times height. That's the part that I just highlighted. Plus, let's pick up our highlighter again. This side here, there's going to be 1 on the other side of that too. So we're going to say plus 2 of those. So that's breadth times height. And then finally, there is a square here at the bottom that is part of the surface area. But remember, there's no square up there because once again, it forms part of the inside of the shape. So we're just going to add 1 of those length times breadth sides. Okay, now we can just substitute in. So 2 times 50 times 120. This is basically checking our algebra while we are doing measurements. This one's going to be 50 times 120. And that final one is going to be 50 times 50. Let's add that up. So if I punch that into my calculator, it gives me an answer of 26,500 centimeters squared. And then to get the final answer, I just need to add those together. So my total surface area is going to be this answer that I just got plus the 2692, 5824, etc. We can round our final answer to 2 decimal places, so 29,192,58 centimeters squared. So there we have the surface area of the shape. Now I quite like it when we can think logically about a shape. I know that there are some people who like to learn a formula and just plug and play. But to me, I enjoy trying to picture what would happen if I break this up. And that helps me to avoid pitfalls like accidentally adding a side that shouldn't be there. So I encourage you, practice as many as possible and make sure that you have a good understanding behind what you're doing and not merely throwing formulas on the page and just trying to fill numbers in. Okay, the more you do it, the more fun it becomes.